An electromagnetic car alarm. Your latest invention is a car alarm that produces sound at a particularly annoying frequency of 3500 Hz. To do this, the car alarm circuitry must produce an alternating electric current of the same frequency. That's why your design includes an inductor and a capacitor in series. The maximum voltage across the capacitor is to be 12 volts. To produce a sufficiently loud sound, the capacitor must store 0.016 joules of energy. What values of capacitance and inductance should you choose for your car alarm circuit? Let's recall the energy stored in a capacitor. The total energy stored in a capacitor, you see, is 1 over 2 CV square, capacitance times the voltage across the capacitor square, which is also equal to the total charge stored, Q squared, divided by 2C. So this is energy stored in the electric field of a capacitor, so it's in the capacitor. All right, so the capacitance of the capacitor is then, in terms of the stored energy, twice the stored energy divided by the potential squared. So that was one of the tasks here, calculate the capacitance we need. And substituting the values here, we have 2 times 0.016 joules of energy stored divided by voltage squared, 12 volts squared. This gives us a capacitance of 223 microfarads. Now, we have this capacitor in series with an inductor. So let's recall the LC oscillator resonance frequency. If we have an LC oscillator, resonance frequency F is 1 over 2 pi 1 over square root LC. Omega is 1 over square root LC, which is 2 pi F, so F is 1 over 2 pi square root LC. So with that, we have 4 pi square F square LC is equal to 1, so that the inductance we need is 1 over 4 pi square F square C. And since the capacitance is twice the energy stored in the capacitor divided by voltage squared, that means the inductance is the voltage squared, voltage across the capacitor squared, divided by 8 pi squared F squared times the energy stored in the capacitor. Substituting the values, the inductance becomes 12 squared, which is 144, divided by 8 pi squared. The frequency 3500 Hz, 3.510 to 3 Hz squared times the energy 0.016 joules, and this gives us an inductance value of 9.31 microhenries. Okay, so in this case, we have designed a circuit which has a capacitor and inductor in series. The resonance frequency is 1 over square root LC, angular frequency. The frequency is 1 over 2 pi 1 over square root LC. We know the stored energy in the capacitor, which is 1/2 CV squared, since we know the voltage across the capacitor, the maximum voltage across the capacitor is 12 volts. So we have the capacitance from 2UC over V squared. And from the resonance frequency, 4 pi square F square LC must be equal to 1. The inductance is 1 over 4 pi square F square C. For C, we have 2UC over V squared. So substituting the values, we find the inductance that is needed to realize this circuit.